All right, so let's start creating our artifacts. The first one would be the general artifact for our application executable, and the other one would be the instance group deployment configuration. So let's click on add artifact. Let's give it a name. Another type, let me select general artifact. Let the artifact source be artifact registry repository. Let's go and select the artifact registry repository. So under the ctdoc compartment, this is the repository that we just created. So let me check this and click on select. Under the artifact location, let's select set custom location. Let's specify the path of the artifact, which is, and also specify the version of the artifact. Now you must be wondering where this exec-app and build_hash came from, right? So it is basically our build_spec.yaml file where we have defined the artifact file name, and we will be using the build_hash in order to assign a unique name to every artifact that is generated after every build run, right? So this is the build_spec.yaml file for this demonstration, where we have specified all the exported variables, we have specified the environment variables, and all the steps has been defined that the build runner would execute when the manage build stage is under execution, right? So in this case, we are installing the Graal VM, we are setting up the path variable, and then we're building a native executable, right, using the mvn command. And under the output artifact section, as you can see, there are two types of output artifacts that would be generated as part of the build, which is the app_native_executable, and another one is the instance group deployment configuration file, right? So let's go back to the console and let's finish up the artifact creation. So let me go ahead and click on add. Let's click on add artifact again to create another artifact, and this time it would be instance group deployment configuration. Let's select the artifact source as artifact registry repository. Let's select our repository. All right, let's go ahead and click on select. Again, in the artifact location, let's select set custom location. Let's give the artifact path, which is our deployment underscore manifest.yaml file. And the version basically is a parameter which will be replaced using the build run hash value. So for that, we'll have to ensure that the allow parameterization has to be checked. Let's go ahead and click on add. As you can see, both the artifacts, artifact 1, which is the general artifact, and artifact 2, which is the instance group deployment configuration, is listed in the artifacts page. So now that we have created an artifact for the instance group deployment configuration file, let's just talk about it. Let me take you to the GitHub repository and let's go to the instance deployment configuration file. The file name is instance_deployment_spec.yaml. Let me click on this file. Basically, the deployment configuration file defines the artifacts to be downloaded to the instance and the location where the artifacts must be copied. The configuration file also specifies the sequence of commands for the deployment, right? So as you can see over here, it is an YAML file, right? So the version is specified. The component for now, the only component that is supported is deployment. Shell over here specifies the shell to be used at the deployment specification global level. So under environments, as you can see, we have variables where you can have the user defined environment variables that are available to the executables or the bash command that run as part of the deployment. And under the vault variables, you can specify the OCID of the secret from the vault, right? Then you have something called files where you can specify the artifacts defined in the deployment pipeline that must be copied and the target compute instance location to copy them to. Right? So you have the source and you have the destination. And then again, you have steps, which basically specifies the list of steps that are run sequentially during the deployment. And each step runs as a different process on the instance. So the step type is defined as command, you give it a name, and then you can specify all the commands that should run within that particular step. As you can see, there are multiple commands that will be executed as part of these steps. So it's basically installing OCI CLI. There's another step that is basically handling failure, another step that is running the application. So if you notice the commands that are mentioned in the run the application step, it's basically downloading the general artifact from the artifact registry repository, and then it is opening up the firewall for particular service, let's say HTTP and 8080. On port 8080 the application would be accessible, and then it is restarting the firewall, then it is setting the executable permission to the appsec file, which is basically the file that they just download, that the instance has just downloaded using the OCI artifact generic artifact download by path command. And then finally it is just executing that particular application in the background, right? And then we have other steps to again handle failures. All right, so this is the deployment configuration file which would be executed on the compute instances created as part of the instance group for this particular demo, right? So another quick step that we'll be doing is, if we check the build spec YAML file, the vault variable over here says that the artifact repo OSID has to be stored as secret, and the secret OSID has to be provided over here, right? So this was basically to show you how vault variables work. So let's go ahead and copy the artifact repo OSID, store it as a secret, and copy the secret OSID and place it over here. Let me quickly go to the artifact repo that we created. So let's go back to the console. Let's go to the developer services, click on artifact registry. Okay, so this is the artifact registry repo, right? So let me go ahead and copy its OSID. Let's go to the vault service. Let's click on identity and security, go to the vault service. All right, so I already have a vault pre-created. Let me click on this vault. I already have a master encryption key pre-created, which we will be using to create our secret. Let's go ahead and click on secrets and click on create secret. Let's give this secret a name. Let's choose the encryption key, which is IGD-MEK. The secret type template is plain text. Let me paste the secret content, which is the OSID that we copied of our artifact repository. Let me go ahead and paste that. Let me click on create secret. So once the secret is active, I'll be copying its OSID and replacing it in the build_spec.yaml file in my GitHub repository. In the meanwhile, let me just open the DevOps project on a different tab. All right, so let's head back to the vault and see if the secret has been created. All right, so our secret has been created and the status says active. So let me go ahead and copy the OSID. And let's paste the OSID over here. Let me go ahead and edit this file. And let me just commit my changes. The moment I commit these changes in my GitHub repo, the thing is that I have created a mirror repository in my DevOps project. So this change should reflect in my DevOps project's code repository. If you notice, the last three alphabets is PTQ for my secret. If I go back to the DevOps project and click on Code Repositories, the code repository, let's click on Files. If you notice, we have the build spec YAML file over here. All right, so as you can see, the change has been replicated. The last three alphabets are PTQ. Basically, this is the OSID of my secret, which is storing the OSID of my artifact repo, right? This is the same. All right, so now that we have confirmed that the OSID for our secret has been replaced, let's go back to the DevOps project. All right, so one important thing to note is, since we are doing deployment to instance group, apart from the usual dynamic groups that we create for DevOps project, we'll also have to create dynamic group for our instance group. So let's go to the identity and security service and create a dynamic group for our instance groups. So let's go to the navigation menu and click on identity and security. Let's click on dynamic group. Let's create a dynamic group. Let's give it a name. And let's specify the rule that defines the resources, basically our instances that we created as part of instance group. So the rule is to add the instance IDs, right? So let's copy this default rule and replace the OSIDs. First, we'll replace the OSID of our first VM and the OSID of the compartment. And let me go ahead and copy the OSIDs and paste it over here. All right, so let me add additional rule for my second instance. Let me copy this and replace the OSID. All right, so I have added both my instances under this dynamic group. Let's go ahead and click on create. All right, so my dynamic group DevOps instance group deployment has been created. Now let's go ahead and write the policy for this dynamic group, which would allow them to use instance agent command execution family in the compartment ctdoc. All right, so let's go to the policies by clicking on identity. Let's click policies over here. And we write policies in the parent compartment. So let me select the parent compartment. And let me click on create policy. Let's give it a name. Let's give it a description and make sure we select the parent compartment of our compartment where we are creating all the resources. And let's click on show manual editor and paste the policy over here. The policy is to allow our dynamic group to use the instance agent command execution family, right? So let's paste the policy over here. So policy is allowing my dynamic group DevOps IGD that we just created to use the instance agent command execution family in the compartment ctdoc, where the request.instance ID is equals to the target.instance ID. All right, so let me go ahead and click on create. All right, so the policy is in place. All right, now since this demo is getting too long, I will break this demo over here and we will continue with the remaining portion of this demonstration in another video. So I hope you enjoyed watching this video so far. See you in the next one. Thank you for watching. Welcome back. Let's resume from where we left last. In the last demonstration, we saw how to create compute instances and add them to the compute instance group by setting up an environment in the DevOps project. We also saw how to create artifact repository and add artifacts to it, like the instance group deployment configuration file and the general artifact. All right, so now that we have all the artifacts and the dependent resources set up, let's go ahead and create our build and deployment pipelines. So let me take you to our DevOps project. Let's click on build pipelines. Let's click on create build pipeline. Let's give it a suitable name. Let's click on create. All right, so now to add the first stage, let's click on this plus icon and click on add stage. The first stage that we'll be adding to our build pipeline is the manage build stage, right? So let's click on manage build and click on next. Let's give this stage a name. Now under select the build runner shape, you can choose either the default shape or you can go for a custom shape. We will go with the default shape. The container image used for the default shape is Oracle Linux 7. Under the build spec file path, we will leave this as blank because our build_spec.yaml file is present in the root directory, which is why we should leave it as blank. Only if the build_spec.yaml file is in a separate location, you need to specify the relative path to that location, right? Let's go ahead and select the primary code repository where these files are present. So let's go ahead and click on select. Let's select the source connection type as OCI code repository. This is the repository where our code is hosted, right, in our OCI DevOps project. So let me select this and let's select the branch as main and the build source name, right? So this is the build source name. Let me go ahead and click on select. So the primary code repository has been selected. There are no additional code repositories that I wish to add, so I'll skip this. And let's go ahead and click on add. All right, so as you can see, the manage build stage has been created with the name build-app-stage. Now the next stage that we will add is the deliver artifact stage. Let's click on the plus icon over here and click on add stage. And from the optional section, let's select the deliver artifacts stage. Let's select the deliver artifacts option and click on next. Let's give this stage a name. All right, so now we have to select the artifacts that we will be delivering, right, to the deployment stage. So let's click on select artifact. And as you can see, these are the artifacts that we had already created in our DevOps project. So let's choose them. Let me choose the first artifact, that is the general artifact, and then the instance group deployment configuration file, and click on add. All right, so the artifacts that we selected are now listed over here. Let's go to associate artifacts with build result section. And here we need to specify the result artifact name. So basically here you specify the name that is present in your build underscore spec.yaml file in your output artifact section, right? Let's go to the build underscore spec.yaml file. And if you notice in the output artifact section, we have these name given to our output artifacts, right? Let's copy these. This one is for the general artifact and paste it over here. And the result artifact name for the deployment configuration file is deployment underscore spec. So let me copy this name and paste it over here. Let's go ahead and click on add. And you will notice that the deliver artifact stage with push-artifact has been added. All right. Now that we have created our build pipeline, let's go ahead and create our deployment pipeline. So let's go back to the DevOps project and click on deployment pipelines from the resources section. Let's click on create pipeline and give this pipeline a suitable name. Let's click on create pipeline. All right, so let's click on this plus icon over here to add the first stage. All right, so under the deploy stages, we have to select the deploy incrementally through compute instance group stage. So let's select this and click on next. Let's give this stage a suitable name. Let's select the environment, which is basically our instance group, right? So let's click on destination and select the environment that we created in our DevOps project, which was env-igd. Let's select this. Now let's click on select artifact and then select the instance deployment configuration artifact file, right? So if you notice, this is the instance group deployment configuration file that would be run on the instances which are part of this instance group environment. So let me click on this and click on save changes. So if you notice, optionally, you can also choose a load balancer to load balance the traffic between different instances in your instance group. For this demonstration purpose, we are not going ahead with load balancer, so I'll skip that. You can also enable the auto rollback option. Basically, it allows you to automatically roll back the release stage if the validation fails. Basically, if the stage fails, it will automatically roll back to the last successful version. Under the rollout policy, you can either select the rollout by percentage or rollout by count option. The rollout policy basically controls the rate and the behavior of the instance rollout across the target environment. When you select rollout by percentage, basically you have to specify the value between 1 and 100, and this value controls the maximum percentage of instances that are deployed or are not running at a time. And if you select rollout by count, you have to enter the count value, and this value will control the maximum number of instances that are deployed or are not running at a time. So I'll be selecting rollout by percentage and I'll be specifying 50%. Basically, this means that only one compute instance will be updated at a time. Delay between batches is specified in seconds, and this is basically controlling the interval between the two rollouts. So basically, after the first instance has been rolled out, it will take a 10 seconds gap and proceed with the second instance. So basically, these two values means that the deployment will first occur on the half of the instances in the instance group, and then on the rest of the half after 10 seconds delay. We also have an optional failure policy that we can select from. So basically the failure policy here defines the failure criteria for a stage. It can be defined based on the number of compute hosts failing in an instance group. So you can choose from none, fail by percentage, or fail by count. These values will define the percentage or the count of compute hosts that will fail after which the stage fails. So I'll be going ahead with none, and let's go ahead and click on add. All right, so as you can see, our deploy incrementally to instance group stage has been created. Now let's link the build pipeline to the deployment pipeline by creating a trigger deployment stage in the build pipeline. Let's go back to the build pipeline. All right, let me click on the build pipeline. And let's add the trigger deployment stage. Let's click on the plus icon over here and click on add stage. And from the optional options, let's select the trigger deployment stage and click on next. Let's give this stage a suitable name. Now let's select our deployment pipeline over here, which is IGD-DP-1. So let's select the pipeline, click on save changes. So ensure that we check the send build pipelines parameters, as we are using parameters in our build pipelines that will be carried forward to the deployment pipelines, right? And if you notice, the artifacts used in the deployment pipeline is pre-selected, which is our instance group deployment configuration file. Let's go ahead and click on add. Great. So our build pipeline is ready and the deployment pipeline is ready. Now we will go ahead and automate the sample web app deployment to instance group. So to do that, we will click on the start manual run. So let's go ahead and click on start manual run. Let's leave the build run name as default and click on start manual run. As you can notice, the manual run has started successfully. And as you all know, these stages would execute in sequential order. The first stage that is getting executed is the managed build stage. All right, so as you can notice, it has completed one of the steps, which will install GraalVM 22.x native image for Java 17. It has also set the path variable. Now it's building up the native executable. In the meanwhile, this managed build stage is running. Let me go to the first tab and open up the artifact repository. Let's go to the developer services and click on artifact registry and select the repository that we created. So basically, after the deliver artifact stage completes, we should be able to see our artifacts present here, right? The generic artifact, that is our executable, and the deployment configuration file. All right, so as you can see, the build stage has executed successfully, and now it has triggered the push artifacts, or you can say the deliver artifact stage. And when it finishes the deliver artifact stage, it will trigger the deployment pipeline. And at the same time, we should also able to see the artifacts in our artifact registry. All right, so the push artifact stage or the deliver artifact stage has completed successfully and it has triggered the deployment pipeline. So let's go to the deployment pipeline now. Let's click on deployments over here and see if there's a deployment in progress. And if you notice, the deployment is in progress. So let's click on this deployment to track the progress. Basically, it's downloading the deployment specification file. It's identifying the instances, which is part of our environment, and then it will start rolling out the deployment. And as we had decided that it should do in percentage manner, that is 50% at a time. So first one instance would be rolled out, and after a delay of 10 seconds, the other instance will be rolled out. So in the meanwhile, this rollout happens, I'll just go and show you the artifact registry. And if I do a quick refresh over here, you can notice that we have two artifacts created under our artifact repository, which is the exec-app, that is our executable, application executable. And this is the deployment underscore manifest.yaml file, which is used to perform the current rollout. Right, so let's go back to the deployment. As you can see, the deployment is in progress. As you can notice, it is starting the first deployment on the instance with instance ID that ends with GQQ. Let's go to the compute instances and copy the instance public IP address. Let me go to the compute service, click on instances. Let me check which one has the OCIR that ends with GQQ. So this one is BZQ. Let me go back to VM02, and that is the VM which is first getting rolled out. So if I select this VM, so if you notice, the OCID is ending with GQQ, which is the OCID of the instance that is getting deployed. All right, so the rollout deployment is complete on the first instance. Let me quickly copy its public IP address and paste it in the URL bar. And remember, the port number that the application is listening on is 8080. So let me give that port number. And there you go. Our application is live on the first instance, which says, hi, you have successfully deployed a sample application to instance group, right? And If we go back to instances and go to the VM1, which is now getting rolled out. So let me copy its public IP address. And let me paste it in the URL bar with the port 8080. And as you can notice, the application is yet not configured on this instance and it will take some time before it gets rolled out, right? So for now, only one instance has been rolled out with the application which is live on it and listing on port 8080. Let's wait until the deployment completes successfully. So as you can see, the second rollout is in the waiting state and it is taking some time. And now it has started its progress because there was a 10 seconds gap that we had specified, right? So after the 10 seconds gap, the rollout is in progress. You can also observe the log to notice that the deployment executed successfully for our instance with OCID ending with GQQ, and it has started deployment on instance with OCID ending with BZQ, which is our VM01, right? So another information that I want to share is I had set up an ingress rule in the default security list for the virtual cloud network that these compute instances are part of, right? So let me quickly go ahead and show you the security list. So this is the subnet. And if you click on the default security list, you should notice that I have added an ingress rule, which is allowing traffic from any IP on port 8080, because this is where my application is listening on, right? Let's go back to the deployment pipeline and see if it has completed. All right, it's still in progress. There you go. So the deployment pipeline has executed successfully. It's completed now. Let's go to the IP of our first VM and hit enter. If you notice, the application has been successfully deployed to this compute instance as well. So both our compute instances now are running this application. All right, so with this, we come to the end of this demonstration where we saw how to use the OCI DevOps project's build and deployment pipeline in order to build your applications and then deploy them to compute instance groups. I hope you enjoyed watching this demo. See you in the next one. Thank you so much for watching. Hello and welcome to our lesson on adding a shell stage in OCI DevOps project's deployment pipeline. In this lesson, we'll delve into how this feature simplifies the execution of custom commands within the deployment pipeline. So let's jump right in. Let's start by addressing the challenges developers faced in previous setups. In the past, setting up deployment pipelines often involved cumbersome processes. Developers had to resort to dedicated VM runners or intricate configurations within the build pipeline to execute even simple bash commands manually. Now, let's explore the purpose behind integrating the shell stage into our deployment pipeline. The purpose of this feature is to empower developers by providing them with the capability to seamlessly execute bash commands and scripts within a container instance host in their tenancy. This significantly streamlines the deployment process, enhancing efficiency and productivity. Finally, let's understand the command specification YAML file and its role in orchestrating the deployment process. The command specification YAML file serves as a comprehensive guide containing all the necessary steps required for deployment. Within this file, developers specify the actions to be executed during the deployment process, ensuring a smooth and controlled deployment experience. Let's delve into the significance of the command specification file in context to our deployment processes. This YAML file holds crucial shell commands and settings executed during deployment, ensuring the smooth progression of our deployment pipeline. The inclusion of command specification file facilitates streamlined management and customization of deployment processes, thereby enhancing overall efficiency. By organizing commands and settings within this file, developers gain clarity and control over the deployment workflow. Furthermore, developers have the flexibility to specify the content inline within the deployment pipeline configuration. This allows for seamless integration of the command specification directly into the deployment process, simplifying the management of deployment tasks. Alternatively, for improved organization and version control, the specification can be stored in an artifact registry repository. This centralized repository ensures easy access to the command specification file, simplifying collaboration and enabling efficient version management. In essence, the command specification file plays a pivotal role in orchestrating our deployment processes, offering flexibility, organization, and efficiency. Let's take a closer look at all the parameters that constitute the command specification YAML file. Starting with version. The version parameter is a mandatory field indicating the command specification version. If this parameter is missing or invalid, it can cause the shell stage to fail, and the supported value for version is 0.1. The next parameter is component. Component is another mandatory parameter that specifies a particular component in DevOps. If this parameter is missing or invalid, it can lead to the failure of the stage. The supported value for component is command. Moving on, timeout in seconds is an optional parameter that allows you to specify the timeout for the entire command specification file. If a value isn't specified, the default timeout of 8 hours is used. The maximum allowed value for timeout is also 8 hours. Make a note, each step in your command specification file, which we will be covering later on, can also optionally have its own timeout value. Next is shell parameter. Shell is an optional parameter used to specify the shell to be used at the command specification global level. If not specified, the default shell used is bash. However, you have the option to choose between /bin/sh and bash. The next parameter is fail immediately on error. This is an optional parameter that determines whether the deployment should continue if any command in the step fails with a non-zero exit value. OCI recommends setting this attribute to true for better error handling. In the command specification file, environment variables allow you to define custom environment variables. The scope of these variables extend throughout the execution of the command specification file. Any modification made to the variable values is immediately reflected in the subsequent steps. These variables serve as environment variables accessible across all steps within the command specification file, ensuring consistent functionality and flexibility throughout the execution process. Vault variable is a type of custom variable where the value is retrieved from the vault using the OCIR of the secret. This variable is available for all steps within the command specification file. Also make a note, the user tenancy must have an appropriate policy defined to allow deployment pipeline resources to access this secret. Exported variables are variables that can be declared and assigned values within the command specification file. These variables are available only within the shell stages of the same pipeline. We'll continue exploring the add a shell stage in the OCI DevOps project deployment pipeline in the next lesson. So stay tuned and I'll see you in the next lesson. Welcome back. Let's continue from where we left off in the previous lesson. Moving on, input artifacts are used to define a list of input artifacts required for running the current shell stage. These artifacts can either be URL or generic artifact type. If you specify the type as URL, the input artifact's external downloadable HTTP URL must be provided. The URL must be publicly available. And you must specify the location. This is the destination path of the local file system where the input artifact needs to be downloaded. And these are the several options that you can choose for your destination path on the local file system. Input artifacts also have other parameters that we must define, and these parameters are mandatory for defining input artifacts. Parameters such as artifact ID, which specify details such as OCIR of the artifact, registry ID, which specifies the OCIR of the artifact registry, path is the destination path of the artifact, and version is the version of the artifact. Remember, these are mandatory parameters for defining input artifacts. And these parameters are required when you set the type of your input artifacts as generic artifact. The next section in your command specification YAML file is the steps section. Steps define the actions to be executed within the command specification file, and each step can have attributes such as name, command, shell type, timeout, on failure steps, and fail immediately on error attributes. The type attribute is a mandatory attribute, and it specifies the type of steps which supports the command value. Name is optional. It is a user-friendly name for the step. Command, both single line and multiple line commands are supported, and all commands specified in one step are run in the same shell session. Shell here is optional. It specifies the shell type of the current step. Timeout in seconds is an optional attribute. It specifies the timeout for the step, and the maximum allowed value is 8 hours. On failure is again an optional attribute. It is a list of steps that must be run on failure to gracefully exit the shell state. And finally, we have the fail immediately on error attribute, again an optional attribute, as it specifies whether the deployment must continue if any command in the step fails with a non-zero exit value. Let's explore the key use cases for incorporating a shell stage into your deployment pipeline. This stage offers versatility and flexibility, enabling developers to streamline various deployment processes. Developers can execute database schema migrations alongside software artifacts deployments to compute platforms within the deployment pipeline. For instance, API changes to Container Engine for Kubernetes can be seamlessly integrated with database schema alterations required by the API modification. Moreover, deploy changes to development or stage environments on the OCI platform, conduct tests, and subsequently deploy to production instances of the service without the need for a dedicated stage. You can seamlessly deploy to non-OCI platforms using the shell stage instructions. This includes deploying to WebLogic environments using WebLogic deploy application command line tools, as well as other local cloud platforms such as Amazon Web Services and Azure using artifacts built from OCI. Additionally, manage applications with dependencies on software as a service resources and environments. Configure commands to interact with services such as Oracle Integration Cloud to ensure smooth interaction with SaaS dependencies during release. Furthermore, conduct integration tests on built artifacts prior to deployment to production. Deploy artifacts to a host for simulating dependent services and validate release artifact sets before deployment to development or staging environment. You can customize DevOps workflows to manage Kubernetes resources effectively, utilize conditional commands to verify application readiness post-deployment, and specify the order of resource creation during application deployment. You can also execute infrastructure provisioning jobs using tools such as Terraform or Ansible with the deployment pipeline. Use the resource principle of the pipeline to create infrastructure for integration test or as part of a deployment strategy such as the Highlander or recreate release strategy. To wrap up, this lesson has equipped us with a comprehensive understanding of the shell stage within OCI DevOps projects deployment pipelines, from exploring its purpose and key parameters of the command specification file to uncovering its versatile use cases. We've gained valuable insights into how this feature streamlines deployment processes and enhances efficiency. I hope you found this video useful. See you in the next one. Thank you for watching. Hello and welcome to this demo on adding a shell stage. In this demo, we'll be walking through the process of adding a shell stage in our DevOps project's deployment pipeline. Let's get started. I'll switch to the OCI console. I have already logged into my OCI Cloud account and this is my OCI dashboard. Before I begin, I'll ensure that I have the necessary policies to begin with this demo. I'll click on the hamburger menu and go to Identity and Security. Here I'll click on Policies. To run this demo, we need a dynamic group for the DevOps deploy pipeline and need certain policies for that dynamic group. Let me go to my parent compartment here. And here is the policies that I have written for my DevOps deploy pipeline dynamic group. So mainly the policies that are required to run a shell stage within your deployment pipeline is to allow your deployment pipeline dynamic group manage the compute container family within your compartment, as well as manage virtual network family within your compartment. So these are the policies that are essential when you are running shell stage within your DevOps deployment pipeline. Now the first thing is we need a DevOps project for this demonstration. I'll go to the DevOps project service by clicking on developer services. I'll click on projects. I'll select the CTD OKE compartment where I'll create my resources and click on create DevOps project. Let's give it a name. And select an ONS topic. I already have a notification topic created with the name DevOps topic. And in case you don't have a topic already created, you must first go and create a notification topic, which will appear in the topic dropdown within the compartment in which you have created it. In my case, I already have a topic created. I'll select that and click on select topic. I'll go ahead and click on create DevOps project. I'll click on enable log and make sure that the logs are enabled for the DevOps project. So I'll leave everything as default. Click on enable log. Now, as we know, we need a command specification YAML file containing all the steps that we want to run during the deployment. In our case, I have an inline command specification which I'll be using, for which we must first create an artifact. I'll click on artifacts within the project resources section. I'll go ahead and click on add artifact, give it a name. Under the type field, we must choose command specification. And under artifact source, you can have your command specification file stored in the artifact registry repository before we create the DevOps project, or you can go for an inline specification. I'll select the inline specification and provide the value of my command specification file here. This is the command specification script which I'll be running as part of this demonstration. Let's understand the command specification here. It starts with a version where we've defined the version of the command specification, which is set to 0.1. Component fields indicate the type of component which is set to command. Timeout in seconds specifies the maximum amount of time in seconds that the command is allowed to run before it is considered timeout, and in this case we have set it to 6000 seconds. Run as specifies the user under which the command will be executed, and here it's set to run as the root user. Shell specifies the shell to be used for executing the command, and in this case it is bash. Steps section defines the sequence of steps to be executed, and in this example there's only one step defined, which is to run a bash command to echo hello via a simple shell stage. And we have set other attributes within this step section, which is type is set to command, timeout in seconds for this command is set to 600 seconds, name of the command is set to run bash command. And we have defined an on failure section over here, which specifies the action to be taken if the steps failed. And in this case, we have just added another echo command which says handled failure with the timeout of 40 seconds. For this example, there are no parameters that we have defined within the command specification file, so it's okay to unset allow parameterization. But in case there are cases where you have defined parameters whose value will be defining during the run period of your deployment pipeline, and in that case, allow parameterization must be enabled. I'll go ahead and click on add. Alright, our artifact shell stage command spec of type command specification, whose source is inline, has been created and is active. Now that we have understood the command specification file, let's proceed to create the deployment pipeline. I'll click on deployment pipelines. Click on create pipeline, give it a name. Click on create pipeline. Within this window, I'll click on the plus icon, click on add stage. And under the integrations section, we have the execute shell command option that's available. I'll click on execute shell command. Click on next. Now here we'll have to provide a name to our shell stage. Description is optional, I'll skip it. And under the command spec deploy artifact, I'll click on select artifact and select the artifact, the inline artifact for the command specification that we just created. Click on save changes. I'll scroll down, and now it's time to configure container instance where the command specification will be run. Well, in my case, the compartment is ctd OKE. I'll leave the availability domain as the default selection. Under the shape field, we have two options. One is CI standard E4 flex and the other one is CI standard E3 flex. You can choose any one based on your requirement. You can also increase the number of OCPUs and memories in GB based on the use case or your requirement. In my case, I'll leave it to the default. Now it's time to select a VCN and a regional subnet within the tenancy. I'll select the one that I've already created. The subnet selection can be public or private subnet. In my case, it's a public subnet. When the command specification file is run, a virtual network interface card, also known as VNIC, is created in the selected subnet, which ensures that the subnet has the network path to the OCI container registry. Also, if you have commands within your command specification that needs to manage other OCI resources, then this must also be handled to ensure that both the network path and the policies are set up correctly. Optionally, for restricting access to your VCN, you can select network security groups in your VCN. I'll be skipping this step. And lastly, you can enter a timeout value in seconds for this stage. I'll go with the default value and click on add. Well, as you can see, we have this shell execution stage created with the name shell demo. I'll go ahead and click on run pipeline and see if our command specification file gets executed. I'll click on run pipeline. And under the start manual run window, we'll go with the default deployment name. Since we don't have any parameters set in the command specification file, we don't have to pass any values here. But just in case your command specification file has any parameters, in that case, you select your stage and specify the parameter name and value over here. Okay, then I'll go ahead and click on start manual run. Well, the deployment is in progress, and I'll quickly duplicate this tab and go to the container instances service page. I'll go to the developer services and click on container instances. As you can notice, we have the compute container instance being created, which will execute the commands specified in the command specification file. that we have defined in the shell stage of our deployment pipeline. Well, the log says the shell execution has triggered successfully. We'll wait until we get to see the echo command that we have defined within our command specification file. Okay, then as you can see, the shell demo pipeline has executed successfully within 2 minutes 29 seconds. And if you scroll down on the logs, here you can see that the bash command that we had mentioned within our command specification file was executed successfully on the container instance. It says hello via a simple shell stage. Now, if I go back to the container instances page, you can notice that the compute container instance is already deleted as it executed the shell command we defined in the command specification file. Now, one thing to note here is you will be charged for the container instance based on the selected compute shape during the deployment based on the pricing model for the container instances. Also note that you can deploy multiple shell stages within your deployment pipeline based on your requirement. You can have them in sequence or have them in parallel. That's totally based on the use case that you're running. With this, we come to the end of this demo. I hope you found this demo useful. See you in the next one. Thank you for watching. Hello and welcome to this lesson on deployment strategies. I am Mahendra Mehra and I am a senior training lead and evangelist with Oracle University. In this lesson, we'll be talking about the blue-green deployment strategy. For any organization in any environment, it is inevitable that the code and the software will need change or a feature upgrade sometime sooner. Deployment strategies are models and practices that enable modification or upgrade of such applications. They allow DevOps teams to define how applications get deployed to the production environment. This section highlights two different deployment strategies, the blue-green strategy and the canary strategy. In this lesson, we will be covering the blue-green strategy and we will cover the canary strategy in the other lessons. You will find a variety of techniques to deploy new applications or updated versions of the existing ones to the production. So choosing the right strategy is an important decision. This allows the administrators to make the right trade-off between the risk of deploying a new release, the impact of the new release on its users, and the infrastructure overhead needed to implement the strategy. Let's understand this with an example. Let's visit our friend Prisha, the DevOps engineer. Prisha is working on building a website that sells medicines. The backend of this website is supported by microservices which handle user identifications, medicines updates, discount programs, and more. Prisha wants to release an update which adds tracking medicine delivery. Mo, who is the solution architect, is impressed by this feature and asks Trisha about what is the wait for. Trisha doesn't really want to wait until midnight when the least number of users are active and then deploy the updated code. She also doesn't want users to experience downtime and lags during the financial transactions. But with such requirements, how can she ensure uninterrupted uptime and stable transactions? Like always, Mo has a solution and tells Trisha about the blue-green deployment strategy. A blue-green deployment strategy allows DevOps team to release a new version of their application by using two identical environments where one of them is active at a given time. The current version of the application is provisioned on the active environment, whereas the new version gets deployed to the standby environment. And both these environments are running in the production. Testing of new updates are done in the green environment. After the testing is completed in the green environment, production traffic is gradually transferred from the blue to the green environment, after which testing of new updates are now done in the blue environment, which is also used in case of rollbacks or as a disaster recovery mechanism. Deploying to the standby environment does not impact the active environment or the user traffic. The DevOps release pipeline can run validation tests against the new version, and once approved, it gets promoted to the production by simply switching the user traffic to the standby environment. This process will repeat for each new version of the application. Using the blue-green deployment strategy, you can deploy the artifacts to two environments. One is the container engine for Kubernetes, also known as OKE, and the other environment is the instance group. In the OCI DevOps service, the blue-green deployment strategy is implemented in 4 stages, of which 2 are optional. The first stage is the deployment stage. In this stage, the two environments are selected along with the artifacts to be deployed. Now, a point to remember here is that load balancer is selected for the instance group blue-green traffic shift, and for the OKE deployment, an Nginx ingress controller has to be set up for routing the traffic. During the deployment run, the new version of the application is deployed to the standby environment. The next stage is an optional invoke function stage. Now in this stage, a custom function can be added to the pipeline just to validate the application in the standby environment. In the third stage, which is a manual approval stage, which again is an optional stage, a manual approval step is added to approve the deployment in the standby environment, and that happens before shifting the production traffic. And finally, we have the blue-green traffic shift stage. And in this stage, after the deployment is validated in the standby environment, 100% of the production traffic is shifted from the current active environment to the standby environment that is running the validated new version of your application. Let's understand this diagram from end to end. For example, let's say we have a microservices-based application which is hosted in a blue environment, and there is a new version of that software which is hosted on the green standby environment. The difference between the two environments is the blue is the active environment which is entertaining the user traffic, whereas the green environment is a standby environment and has no user traffic coming its way. Now in the next stage, what can be done is you can use functions to validate the deployments in the green standby environment. Once the function validates the software running in the green standby environment, it can be further moved to a manual approval stage where a manual approval is given to the software running in the green standby environment. Once all the required approvals are in place, we now need to switch the traffic from the blue active environment to the green environment. So here the load balancer now would point to the green environment which becomes active, and the blue environment goes into the standby state which is hosting our old software version, whereas the green environment now hosts the new validated software version. So this is how we deploy new applications or updates to the existing one without affecting the existing user traffic. Let's take a look at the blue-green deployment benefits. The main advantage of this strategy is that it offers near zero time during the software deployments. Also, if a deployment fails, your users won't even notice that something ever happened. Quick rollbacks. The reverse process is equally fast because blue-green deployments utilize two parallel production environments. You can quickly switch back to the stable one should any issue arise in your live environment. Another advantage for blue-green environment is A/B testing. You can load new features onto your idle environment and then split traffic with a feature toggle between your blue and the green systems. You can then collect data from those split user sessions, monitor your key performance indicators, and then if analysis of the new feature looks good in your management system, you can switch traffic over to the updated environment. no downtime. Blue-green parallel production environments also make load balancing very easy. When the two environments are functionally identical, you can use a load balancer to route traffic to different environments as needed. Let's also take a look at some of the drawbacks of blue-green deployment strategy. Resource intensive. It is evident by now to perform a blue-green deployment, you will need duplicate resources. And to maintain two production environments is not an easy task. The cost of this in money and skilled manpower might be too high. The other drawback is error encountered when changing user routing. So when managing a release between two identical environments, you need to closely monitor both the environments for issues. One issue is that during the initial switch to the new environment, some sessions might fail or users may be asked to re-log in into the application. Similarly, when rolling back to the blue environment or the old environment, in case of an error, users logged into the green instance may face service outages. Managing database dependencies between deployments can be complicated. It's because the process of maintaining two clones of production and pushing only one of them live can cause all kinds of database problems. For instance, what if the database schema is going to be changed as part of the new release in the blue environment? The green environment with old code will not function with that database anymore. So to wrap up, in this lesson we discussed the importance of deployment strategies. We covered the OCI DevOps blue-green deployment strategy in detail, including the pros and cons of using it in your delivery process. I hope you liked this lesson. See you in the next one. Thanks for watching. Hello and welcome to this demo on blue-green deployment strategy. I am Mahendra Mehra and I am a senior training lead and evangelist with Oracle University. In this demo, we will be building a container image for a sample Python application. We will be storing it in our container registry to be later deployed to the Oracle Container Engine for Kubernetes using the OCI DevOps deployment pipeline with blue-green deployment strategy. Alright, so let's get started. So this is the OCI console I've logged into, and in the interest of time, I've already created a few resources which I'll be using during this demo. So let me quickly show you the resources that I have pre-created. So the first resource is the Oracle Container Engine for Kubernetes, which I've already created. So this is my OKE cluster that's spun already, and if I click on it, I can take access to this cluster using access cluster, and I'll be using the Cloud Shell access. So just copy this command and let me just duplicate this tab. Let me bring up the Cloud Shell. Now let me set up the access to our cluster that I've already created using the Cloud Shell command that I just copied. Alright, so the kubeconfig file has been written. Now let's just check whether we have the cluster access using the kubectl command. So I'll be firing the kubectl get nodes command. There you go. So the nodes have been returned and we can be assured that the cluster is accessible using the command line. Alright, so let's get back to the first tab, close this. And the other service that I've already configured is the GitHub personal access token as a secret in a vault. So let me take you to the vault. So this is the vault DevOps demo. If I show you the secret, I've already created a GitHub-pat secret which contains the personal access token of my GitHub account. So if I take you to my GitHub account, this is the GitHub repo which I'll be cloning into the DevOps code repository from where all the source code and the build_spec file and the deployment manifest file will be pulled, right? And again, this is a forked repo of Oracle DevRel GitHub repo where all the examples of various services are hosted for instructional purpose. Alright, so let's jump back to the OCI console. Alright, so the first task for this demo is to create a container registry. So I'll be going to the developer service and where I'll select the container registry and make sure that the compartment selected is the compartment where you're creating all your DevOps resources. For me, it's ctdoc. So let's click on create repository and give your repository a name. So I've given my repository a name and I'll select the access type as public. Click on create repository. Alright, so our repository has been created and currently it has no images available with it. Alright, so let's move on to the next step where we'll be creating an OCI artifact within the artifact registry. So let's click on this hamburger menu, go to the developer service and click on artifact registry. Let me create a repository. Again, make sure that the compartment is the same compartment where all your DevOps resources are being created. Let me click on create repository. Let me give it a name. Make sure that the immutable artifact is set to enable and then we'll click on create. Alright, so as you can see, the artifact registry has been created. Alright, so our artifact registry has been created with this name. So moving on with the next task, which is to create a new DevOps project. So for which I'll click on the hamburger menu, go to the developer services and click on DevOps projects. Make sure the compartment is the compartment where all your DevOps resources are being created. For me, it's ctdoc. Let me click on create DevOps project and give my project a suitable name. So one thing which is important is your DevOps service will need a notification topic in order to send messages for important events whenever we run our build and deployment pipelines. So let's go to the notification service and create a topic for this particular project. So let me go to the another tab and let me minimize this Cloud Shell. Let's go to observability and management and click on notifications. Let's create a topic for our project. Alright, so let me click on create. Alright, so our notification topic has been created, which is mr-devops-bg-notification. And there exists one more topic for our different project. So let's ignore that for now. Let's get back to our first tab and select topic. So under the topic, if you click on this, we get to see the topic we just created for this project. So let's select that and click on select topic. Let's click on create DevOps project. Alright, so as you can see, there's a warning to enable logging. Let's click on enable log. And let's enable the log by setting the slider to enable. Let's leave everything as default. Let's click on enable log. Alright, so the status for DevOps log is creating. Alright, so as you can see, the DevOps log for this project is now active. Let's click on the project overview. And as you can see, the warning is now gone. Alright, so now the first thing that we will be doing under DevOps project is to mirror our existing GitHub repo into the code repositories. So let's click on code repositories. And select mirror repository. Click on the connections, click on create connections, give this connection a name and select the type as GitHub. Let's select the vault as DevOps-demo and let's select the secret which stores our GitHub personal access token and let's click on create. So once the connection is successfully created, we will be able to see the list of repositories in my GitHub account. So as you can see, within my GitHub account, I have these many repositories. For the current demo, I'll be using the Python OCI blue-green OKE app repo. So let me click on this. And you can choose the scheduling type from once, default or custom. Let me select custom and let me set it to 2 minutes. So every 2 minutes, my code repository will sync the mirror. And let's leave the name as the default name that was auto-generated. And let's click on mirror repository. So as you can see, the mirroring is in progress. It will take some time before we'll see all the files at this location. Okay guys, so as you can see, our code repo has all the files from my GitHub account now, right? So let's move on to the next task. So let's get back to our DevOps project by selecting the DevOps project name from the breadcrumb. Now let's create the DevOps artifacts for our project, which is the container image artifact and the Kubernetes manifest file. So let me click on artifacts from the menu available on the left. Let's click on add artifact. The first artifact that we'll be creating is for our container image repository. Let's give it a suitable name. Select the type as container image repository, and here you'll have to specify the fully qualified path to the image in your container registry. So we had just created container registry as part of our first task. Let's get the full path to that container image registry. So let me take you to the container registry. Alright, so this is the repository that we had created. We need to provide the fully qualified path to this repository. So the syntax is, you need the repository name, and the syntax is regionkey.ocir.io / the tenancy namespace / the repository name : the tag. So I am currently running in US East Ashburn, so my region key is iad.ocir.io / my tenancy is int oracle rohit / the name of my repository : and here you have to specify the tag. So basically in our case, the tag is a parameter that will be passing, and the parameter name is build_run_hash. So let me quickly take you to the build_spec.yaml file. And as you can see in the build_spec.yaml file, we are using this exported variable called build_run_hash, which will be used as a parameter throughout our build pipeline, right? So we will be using this to give our image a unique name, right? So let's get back here and provide this tag as a parameter. Alright, so I've added the fully qualified path to the image in our container registry, and make sure you set the allow parameterization, because this is the parameter that needs to be set while we run the build pipelines. So let's click on add. So the next artifact that we'll be creating is for our Kubernetes manifest. Let's click on add artifact, give it a suitable name. Make sure the type is selected as Kubernetes manifest. So now let's select the artifact registry repository that we had created earlier. Click on select. Make sure that you are in the right region and the right compartment, and select the artifact registry repository that you had created. For me, it is this one. Let me click on select. Now click on the artifact location drop down and select set custom location. Now let's give a suitable name to the artifact, which is, and of course in the version, what we'll be doing is we'll be providing the build_run_hash parameter, because we are using that parameter as version for all the artifacts that we are generating. So let's use the parameter build_run_hash. Make sure that you write the parameter using the syntax as starting with $ and within the curly braces, and make sure you check the allow parameterization field. Alright, so let's click on add. Alright, so as you can see, we have created two artifacts. One is the Kubernetes manifest to be used for deployment in the OKE cluster, and the other one is the Docker image artifact to be used while the deployment is running, or basically when you pull the images for the deployment to be ready. Alright, so let me end the video here, and I'll see you in the next video with the remaining task. Thanks for watching. Hello and welcome back to this demo on deploying to OKE using blue-green deployment strategy. So let's resume from where we left in the last video. All right, so the next task is to create a build pipeline. Let me click on the build pipelines from the left menu. Let's click on create build pipeline and give this pipeline a suitable name. Let's click on create. So our build pipeline has been created and we get to see the dashboard where we will be adding different stages to our build pipeline. So the first stage, that is the default stage that we need to add, is the manage build stage. Let's click on add stage over here and click on manage build. Let's click on next. All right, so let's give this stage a suitable name. So let's leave the build agent compute shape as default, the container image as default, and let's go down. All right, so as we had learned earlier that build_spec.yaml file should be present in the root of your code repository. If it is not present there, you need to specify the relative path to it. In our case, it's present in the root, so we will leave it as it is. Let's select the primary code repository. Let's select OCI code repository where we have mirrored our primary code repo. Let's select the repo name. Let's select the branch as main and provide the build source name. So I've provided a build source name, which is basically a directory that will be created in our build runner where all the source code will be pulled. All right, so let's click on save changes. Let's leave everything as default and now click on add. All right, so our first stage has been added, which is the manage build stage, whose name is build Python application. Right, so we all know the manage build stage will basically execute all the steps given in the build_spec.yaml file, which is present in the root of your code repository. So if I take you to the code repository, this is the file, build_spec.yaml file. Let me go to the root. Right, so this is where it is present. And if I give you a quick walkthrough, so as you can see, we have an exported variable called build run_hash. And then we have this input artifacts, which will be used by the build runner to start with. And then again, we have different steps configured. They have different commands. So first one is defining unique image tag. And then that unique image tag will be stored in this parameter. Right. Then again, we have a command where we are building the container image. And we have the output artifacts section where the container image and the deployment manifest are forwarded to the next stages, right? And we have to make sure that these names are used, right? So we'll be seeing that further in the demo. All right, let's get back to the build pipeline. Now that we have created the manage build stage, the next step would be to create a deliver artifact stage. So let's click on this plus icon, click on add stage. And here we need to select the deliver artifact stage. Select the deliver artifact stage, click on next. Give this stage an appropriate name. And you have to select the artifacts that you wish to deliver. Right, so let's click on select artifacts. And these are the two artifacts that we need to deliver. Right, so let's select both of these. One is the Kubernetes manifest and another one is the Docker image. Right, so let's click on add. Now the next important thing is to provide the artifact associated with the build result, right? So you need to provide these two names, and where do you get these two names from is from the build_spec.yaml files output artifact section. So let's get back to the build_spec.yaml file, and if you see, we have these names given to both our output artifacts, right? So let's select the name for the Docker image and provide it for the Docker image here. And let's also populate the name for the Kubernetes manifest, which is OKE_deploy_manifest. All right, so now this is done. Let's click on add. All right, as you can see, the push artifact stage or the deliver artifact stage has been added with the name push artifacts. Okay, so the next thing that we have to do is create a DevOps environment. So let's go to our DevOps project. Let me click on the DevOps project name in the breadcrumb menu. And here we need to set the DevOps environment where we'll be deploying our application into. So we know that we'll be deploying it to the OKE cluster, which we have pre-created. So let me click on environments and add that environment over here. All right, so let me click on create environment. Make sure that the environment type selected is Oracle Kubernetes Engine. Give it a suitable name. Alright, you can leave the description as blank. This is optional. Let me click on next and select the cluster where we wish to deploy our Python application. So let me select the cluster that I had pre-created, which is mr-devops-bg-oke. Let's select the cluster. Make sure the right compartment is selected when you choose the cluster from the list. Click on create environment. Alright, so the environment has been successfully created. Once this environment is created, we will go ahead and create our deployment pipeline. So let's click on the DevOps project name and this time select deployment pipelines. Let's click on create pipeline and create a deployment pipeline with a suitable name. And let's click on create pipeline. Alright, so as you can see, the deployment pipeline has been created and we are seeing this dashboard where we can add different stages to it. So let's click on add stage. Alright, so as you can see from the different options that we have, you must be familiar with a few of them which we had already covered in previous lesson. In this one, we'll be working on the blue-green strategy. So let's select blue-green strategy and click on next. Now let's fill up all the required fields here. Let's select the deployment type as OKE since we are deploying to the Oracle Container Engine for Kubernetes. And let's give this stage a name. Let's select the environment, that is the destination that we had created in the DevOps project, which is OKE_polyglot_dev_environment. And now here you need to provide the namespaces. So as we all know, blue-green deployment uses two namespace. So let's provide the namespace name for both namespace A and namespace B. In our case, we'll be using ns-green as one namespace and ns-blue as another. Now let's select the artifact that we want to deploy to this OKE cluster. Let's click on select artifact and provide the artifact name, which is our Kubernetes manifest. Alright, so let's select this and click on save changes. Alright, so it's asking us for the nginx ingress name for this deployment. We have declared the nginx ingress in the deployment.yaml file. Let me take you to the code repository again. And if you see, we have this OCI-OK-deployment.yaml, which is our deployment manifest file. And if I scroll to the bottom, we can see that we have an ingress defined over here. And the name of the ingress is sample-oke-bg-app-ing. So let me copy this name and provide this as an input to nginx ingress name. Alright, so we have populated all the details. Let's click on next. Alright, so if you recollect from the theory lessons, we also have an option for the validation controls where you can define a function which tests your deployments. But since it's a demo and in the interest of time, I'm just leaving it to none. And again, under the approval controls, I'll set it to enable and give this stage a name. And let's leave the number of approvers as 1. Let's click on add. Alright, so the stages have been successfully created. Let's click on close. Alright, so as you can see, our blue-green deployment strategy and the stages for it are created in the deployment pipeline. So the first one is the blue-green OK deployment stage. The next one is the control approval stage. And the third one is the OK traffic shift stage. Alright, so once the deployment pipeline is created, we must go back to the build pipeline and create another stage called trigger deployment. So for that, let's click on the DevOps project name in the breadcrumb and select the build pipelines. Let's go to our build pipeline and add a trigger deployment stage over here. Let's click on this plus icon, click on add stage. And from the optional section, let's select the trigger deployment stage. Click on next. Give this stage a name. Alright, so let's select the deployment pipeline. So this is the deployment pipeline currently available in this DevOps project. Let's select this, the one that we just created, and click on save changes. Make sure that send build pipeline parameters is set to enable. And let's go ahead and click on add. Alright, so the trigger deployment stage has been added to our build pipeline. Alright, so now we have created the build pipelines and the deployment pipelines. There's one thing that's missing, and if you remember from the lessons, I told you that for OKE deployment using blue-green deployment strategy, we need an nginx ingress controller which has to be set up for routing the traffic. So let's go ahead and set up the nginx ingress controller in our OKE cluster. Alright, so let's go to the Cloud Shell and set up our ingress controller. Let me go to the next tab where our Cloud Shell is active. The first step to create your Nginx ingress controller is to create a cluster role binding. So if your Oracle Cloud Infrastructure user is not a tenancy administrator, you need to grant the user the Kubernetes RBAC cluster admin cluster role on the cluster, right? So for which the command is, alright, so the command is kubectl create cluster role binding, and this is the string of your choice that you wish to give. It is used as the name for the binding between user and the Kubernetes RBAC cluster admin cluster role. And then you have to specify double hyphen cluster role equals to cluster hyphen admin, and then provide the user OCID. Let me hit enter. And as you can see, the cluster role binding has been created. Let me clear the screen. So the next step is to create a service account and the ingress controller. So you can run the following command to create the ingress nginx controller deployment along with the Kubernetes RBAC roles and bindings and the ingress controller service of type load balancer. So let me go ahead and hit enter. Make sure you always choose the latest version. So as I'm recording this video, the latest version is 1.3.0. So as you can see from the output, the role binding services and various config map and deployments were created for ingress nginx controller. You can also view the list of running services by entering the following command. So as you can see, the ingress nginx controller has been created of type load balancer and the external IP is yet to get assigned. So let's wait until this gets assigned. Alright, so the external IP is assigned to the ingress nginx controller. Now let's create a file with the code in it to define the ingress nginx ingress controller service as load balancer. So let me use the code editor to create that file. Let's click on the code editor from the top right menu. Alright, so as you can see, the code editor has launched. Let me maximize this. And within my home directory, let me create a file. Alright, so my file is created. Let me paste the code. Alright, so as you can see, we are creating a kind service for ingress nginx where we are defining the type as load balancer. Alright, so let's save this file. Let me minimize this window. And now by using the file I just saved, let's create the ingress-nginx ingress controller service by running the command kubectl apply space -f and the name of the file. And let's hit enter. Alright, so as you can see, now the nginx ingress controller has been set up properly. Just to validate, let me use the kubectl get spc command. And let me hit enter. So as you can see, our ingress nginx of type load balancer has been deployed and it has received a public IP. Alright, so with this we have set up the nginx ingress controller. Now the next thing that we have to do is create two namespaces for the deployment. So if you remember from the deployment pipeline, we had given two names for namespace A and namespace B, which was ns-blue and ns-green. So let's create that namespace using the kubectl command. So the command to create the namespace is kubectl create ns space the namespace name. So I'm providing two commands in the same line to create two namespaces, that is ns-blue and ns-green. Let's hit enter. And as you can see, the namespace has been created for both ns-blue and ns-green. Alright, so with this we have completed the entire setup for the blue-green deployment strategy. Now we will be running the build pipeline to see the entire thing in action. Alright, so I'll be stopping this video here. So I hope you enjoyed the demo so far. Thanks for watching. Welcome back to this demo on blue-green deployment strategy. So in the previous demo, we saw how to create artifacts, environments. We created namespaces for the blue-green deployment strategy. We built an entire DevOps project with all the requirements such as artifacts, environments, build, and deployment pipelines. Now in this video, we'll be taking it forward and we'll be actually going ahead and running those build pipelines and deployment pipelines to see the blue-green deployment in action. So let's click on Start Manual Run. Alright, so it brings you to the Start Manual Run page. Click on the Start Manual Run button at the bottom. And as you can see, the manual run has successfully started. On the left hand side, we have this flowchart which indicates how various stages would execute one after the another. And in the middle, we have the build run progress window where you can see the build run progress. And on the right hand side, we have the log window where you can view all the logs. So at present, the build Python application stage is running, which is the manage build stage. A build runner is getting provisioned and which will run the build_spec.yaml file that we had provided as input. So what happens after the manage build stage executes successfully is we get a container image holding our Python application, and that image is then sent to the container registry. If I go to the container registry, and this is the repository that we had created, currently there is no image in this repository. Once the manage build stage executes and the deliver artifact stage executes successfully, it will push that artifact in the container registry. Alright, so let's wait. And another point to note is you must always keep a look at the logs, because this is where you'll find out whether your build is executing successfully or not. So in case of errors or failures, you can look through those logs and figure out what went wrong. Alright, so the manage build stage has completed successfully and the Python application has been built. Now the build pipeline is running the deliver artifact stage where the artifact, the container image, will be pushed into the container registry. And once the image is pushed into the container registry, the trigger blue-green deployment pipeline will execute and the deployment pipeline will start its execution. So let's wait. If you notice the log, the starting OCIR upload for artifact has started, and this is where the image will be uploaded in our container registry in this repository that we had created earlier. Alright, so as you can see, the deliver artifact stage has executed successfully, and if you go to the container registry and refresh the repository, this is basically the build run hash, the tag that the image has got. And let's wait for it to trigger the deployment pipeline now. Alright, so the deployment pipeline has been triggered. Let's go to the deployment pipeline. Let me click on the DevOps project in the breadcrumb. Let's click on deployment pipelines. This is the deployment pipeline. And let's click on deployments to see any deployments in progress. Alright, so there is one deployment in progress. Let's click on that. As you can see, there are these three stages that will get executed. So as you can see, the first deployment is successful and our Python application has been deployed to namespace A. And if you remember, the namespace A was ns-green. Let's validate the deployment, for which we'll have to go to the Cloud Shell. And let's fire this command. So as you can see, our namespace ns-green has 3 pods running in it, and basically it also has an ingress with a public IP address. So which means our application was deployed on ns-green namespace within our Kubernetes cluster. And currently the ns-blue namespace, which was the namespace B of our deployment pipeline, is empty, right? So let's quickly check our application by going to this IP address. Let me copy this and let's hit this IP address. So as you can see, it says message with love from OCIR DevOps, and the version is 0.1, and the namespace it is deployed on is ns-green. Alright, so let's go back to the deployment pipeline, and now the deployment pipeline is waiting for manual approval. So let's click on these 3 dots over here and click on approve. Give a reason for approval. Let's say test passed. Click on approve. So once we click on approve, it will start executing the blue-green deployment traffic shift stage. And as you can see, the traffic shift stage has completed and the traffic is currently diverted to ns-green namespace, which is where our application is deployed as of now. So if you go back to the load balancers IP and hit refresh, the traffic is still on the ns-green namespace, right? Now it's time to make some changes in our code and see whether the blue-green deployment strategy pushes the code in a new namespace, which is ns-blue for us. So let's go back to the code repository and make some changes in our Python application. So let me go to my GitHub repo and let's make changes in main.py. All right, let me edit this file. And if you see, the version is 0.1 for now. Let me change it to 0.2. And let me change the message to with love from OCI DevOps team. All right, so I've made these two changes, the version and the message. So let's commit these changes. All right, so I've made the commit in my GitHub repo. And as you all know, we have mirrored this into our DevOps project code repository. So within 2 minutes of interval, the mirror will get synchronized. Let's go back to the DevOps project. Let me duplicate this tab and let me go to the DevOps project. Let's go to the code repository. This is the code repo that we had mirrored. So let's click on that and just quickly check whether the new changes have been reflected back to our code repository. So as you can see, the mirroring is in progress and we have made the changes in main.py file in our GitHub repo. So those changes should be reflecting over here. All right, as you can see, the version has changed to 0.2 and the message where I've added team towards the end, right? So these are the changes that have been reflected in our code repository. It's time to go back to our build pipeline and do a new manual run to see if the new application or the changed application is getting deployed to a new namespace. So let's go back to the build pipeline. Let me click on the DevOps project name. Let's click on the build pipelines. Let's click on the build pipeline name and start the manual run. Click on start manual run. As you can see, the manual run has started. It will repeat the similar steps. That is, it will build our application, create a container artifact, push that image into the container registry, and then trigger the deployment pipeline. All right, so as you can see, the build Python application stage has executed. It's currently doing the deliver artifact stage. All right, so the push artifact stage has completed. Now if I take you to the container registry, and if I refresh the repository, you will see there's another image that just got created, right? So this will be used for deployment. Now let's go back to the pipeline, and the trigger deployment pipeline has executed. And if you notice, the entire build took around 7 minutes, right? So let's go to the deployment pipeline now and see the new deployment in progress. So as you can see, this time it's deploying the application in a different namespace, which is ns-blue, since the modified version of our Python application is getting deployed. Now let's quickly validate if our ns-blue namespace has valid pods created and deployment created within it. So let's go back to the Cloud Shell and run this command. So basically what this command does is it uses a for loop to switch between the two namespaces ns-green and ns-blue to check for pods and ingresses. There you go. So as you can see, we already had our ns-green namespace running the previous version of our application, and this time we have the ns-blue namespace which is running the latest version of our application. Now once we have validated that the pods have been created in the ns-blue namespace, let's get back to the deployment pipeline. And as you can see, the deployment pipeline is waiting for approvals. Since we had set manual approvals to move the traffic from one namespace to another, we'll have to provide the approval by using these three dots. We'll click on approve and provide the reason for approval. And then click on approve. So once we approve, the traffic shift stage will start executing and the entire traffic will be shifted from the ns green namespace to ns-blue namespace. Alright, so the traffic shift is complete. Now let's go back to the load balancers IP and hit refresh to see that our new changes have been deployed. Alright, so the version is now 0.2 and the message is with love from OCI DevOps team. So team is the word that I added in the latest code. So now you can continue the other reruns from the build pipeline and validate the switch between environments. So with this, now there's one more thing that we can try is a manual rollback. So let's go back to the deployment pipeline and click on the 3 dots over here in the traffic shift stage and select the revert traffic shift. So this brings us to the deployment input page where we have to specify the target deployment information. So there was only one deployment previous to this, which is this build run hash. All right. So if you go to the container registry, and if I show you this is the previous deployment, right? So this image was deployed in the ns green namespace. So we want to switch back to this particular image or this particular Python application. So let's go back to the build pipeline, and this is the one that we will be selecting. So let's click on revert traffic shift, and the rollback has started. So once the rollback finishes, that is, the traffic now will shift again to the ns green environment, or you can say the ns green namespace from the ns blue namespace. All right, so the traffic shift has completed, and as you can see, it has moved the traffic to ns-green namespace. Let's go back to that load balancers IP and hit refresh to see if we get to see the previous version of our Python application. All right, so as you can see, it's moved back to 0.1, and the message again, the team from the message has gone, and the namespace is ns-green. So with this, we come to the end of this demo where we saw how to use the OCI DevOps deployment pipeline with blue-green deployment strategy to push applications onto the OKE cluster. I hope you enjoyed the demos. See you in the next one. Thanks for watching. Hello and welcome to this lesson on deployment strategies, and in this lesson we'll be covering the Canary deployment strategy. I am Mahendra Mehra and I am a senior training lead and evangelist with Oracle University. Canary deployment is a technique to reduce the risk of introducing a software update in the production by slowly rolling out the change to a small subset of users before making it available to everybody. Initially, the new version gets deployed to a Canary environment with no user traffic. The DevOps release pipeline can run validation tests against the new version, and once ready, route only a subset of users to the Canary environment. This technique allows the DevOps team to evaluate the new application version against real user traffic, gradually increasing the user traffic to the new software version deployed in the Canary environment. They can compare the two application versions side by side before rolling out the new version to a larger user base. It also offers risk mitigation because the new version is only enabled for a small subset of users. These users can easily switch back to the previous version if any issue arises. You can deploy artifacts using Canary release strategy for Container Engine for Kubernetes, also known as OKE, and instance group deployment. In the OCI DevOps service, the Canary deployment strategy is implemented in 5 stages, of which one is optional. Stages are individual actions that take place during a run of a pipeline. Let's take a look at the stages for the Canary deployment. The first stage is the Canary deployment stage. In this stage, a Canary environment, which can be an instance group or an OKE, is selected along with the artifacts to be deployed. Remember, load balancer is selected for the instance group Canary traffic shift, and for OKE deployment, Nginx ingress controller has to be set up for routing the traffic. During the deployment run, the new version of the application is deployed to the Canary environment. The next stage is the invoke function stage, which again is an optional stage. In this stage, a custom function can be added to the pipeline to validate the deployment in the canary environment. The invoked function tests the new version before moving to the production environment. The third stage is the traffic shift stage. In this stage, part of the production traffic is shifted to the canary environment. The fourth stage is the manual approval stage. In this stage, a manual approval step is added to approve the deployment in the canary environment before deploying the application in the production environment. And finally, we have the production stage. In this stage, a production environment, it can be an OKE or an instance group, is selected, and the application that is validated in the canary environment is deployed to the production environment during the deployment run. Let's understand this diagram from one end to another. Let's assume you already have a software application hosted on one of the environments on the OCI platform. Now you wish to update that software to a newer version. For that, you must first have a canary environment created. It can be either in the container engine for Kubernetes or it can be an instance group. You deploy your new software version in one of these environments. You can optionally choose to have a custom function which can validate the new software version. And once validated, you move on to the traffic shift stage where you shift some of the user traffic to the canary environment where you have deployed the latest validated new software version. Now, based on the user's reception of your new software version, you can also have a manual approval stage where you can decide whether the deployment in your canary environment should be moved to the production environment. And once that approval has been received, your load balancer now can move all the traffic from the original environment towards the canary environment where you have the latest updated version of your software running. Let's take a look at some of the canary deployment benefits. One of the benefits it offers is real-world testing. Canary deployment allows organizations to conduct small-scale real-world testing in production with real users and use cases and compare different service versions side by side. The another advantage is rollback. It is fast and safe to trigger a rollback to the previous version of an application. In case of any issues with the working version of the application, the users are rerouted to the stable version and the canary nodes are rolled back to the previous code state. And lastly, there is zero downtime while updating or releasing the new feature. Let's also look at some of the drawbacks of canary deployment. One of the drawbacks of canary deployment is more overhead. Canary deployments share same complexities as blue-green deployments. Having many production machines, migrating users between the production systems, and monitoring the new system, these are all complicated tasks. Another drawback is slow rollout. Scripting a canary release can be complex. Manual verifications or testing with limited real-world users can take time. Observability. Testing and validating a new release at scale can be complex. The monitoring and feedback systems for the infrastructure should be modified to monitor the canary deployment separately, which may involve additional research. Users are still exposed to software issues. While the whole point of a canary deployment is to expose only a limited users to a new feature, you will still expose end users to the less tested code. Remember, the first group using the canary will find the worst bugs leading to poor user experience. To wrap up, in this lesson, we discussed the OCI DevOps canary deployment strategy in detail and understood how canary deployments allow us to do controlled trials with real users. When we combine this strategy with OCI DevOps CI/CD workflow, we get a productive, feature-rich release cycle. I hope you found this lesson useful. See you in the next one. Thanks for watching. Hello and welcome to this demo on Canary Deployment Strategy. I am Mahendra Mehra and I am a Senior Training Lead and Evangelist with Oracle University. In this demo, we will build a container image for a sample Python application, just like we did for the previous demos. We will then store it in a container registry to be later deployed to Oracle Container Engine for Kubernetes using the OCI DevOps deployment pipeline, this time with canary deployment strategy. In this setup, we will expose a new version of the already deployed Python application to a small portion of our production traffic and analyze its behavior. And after we feel confident that the new changes are good to go, we will roll out the changes to the rest of the users. In the interest of time, I have already created a few resources which I'll be using during this demo. So let's get started. Alright, so I have logged into the OCI console. Let me quickly show you the resources which I have pre-created. So one of the resources that I've already created is the Kubernetes cluster. Let me show you the Kubernetes cluster that I've already created by going to the developer service, click on Kubernetes cluster. And as you can see, this is the Kubernetes cluster that we'll be using in this deployment, which is mr-devops-canary-oke. Let me click on this and let's quickly take the cluster access. So let me click on access cluster. Let me copy this command, open up the Cloud Shell and paste this command over here so that we can access the cluster using Cloud Shell. Let me hit enter. Alright, so the kubeconfig file has been written with the cluster details, and let's see if we can access the cluster nodes using the kubectl command. Alright, as you can see, we have the nodes created and we are able to access the cluster using the kubectl command from the Cloud Shell. Let's move ahead and let me show you the other services that I have pre-created. So the other thing that I have pre-created is the secret for my GitHub personal access token under the OCI Vault service. So let me take you to the OCI Vault service. Let me close this. Let me click on the hamburger menu, go to identity and security and click on Vault. So within my compartment CityDog where I'm creating all my DevOps resources, I have this vault created called DevOps-demo. And if I click on secrets, this is the secret that I had created, GitHub-PAT, which is my personal access token from my GitHub repository, where I have hosted the entire code for this sample Python application. Alright, so moving on, the next service that I had pre-created is a notification topic for my DevOps project. So let me take you to the notification topic. Let me click on the hamburger menu, click on observability and management, and click on notifications. So if you see within my CityDog compartment, I have this new topic listed over here, which is mr-devops-canary-notification. So I'll be using this notification topic when I create my DevOps project. Alright, so with this, I've shown you the resources that I have pre-created for this demo. So let's begin with the first task in this demo. So the first thing that we'll be creating as part of this demo is the container repository to host our sample Python applications container image. So let me go to the hamburger menu and click on developer services. Let's select the container registry. So you must ensure that you create the repository in the compartment where all your DevOps resources are maintained. In my case, it's CityDog. So let me go ahead and click on create repository and give my repository a suitable name. And let's select the access type as public and click on create repository. Alright, so as you can see, my repository has been created with the name mr-devops-oke-canary-sample. And if I show you, there's no image at present within this repository. So the next task is to create an OCI artifact registry, for which I'll click on the artifact registry, which is available in the left menu, and click on create repository. Give my artifact repository a name. Alright, so I've given my artifact repository a name, and make sure that it is created in the same compartment where your DevOps resources are created. And just ensure that you check the immutable artifacts field and click on create. Alright, so as you can see, our artifact registry has been created. So next up is we have to create the DevOps project. So let's go to the DevOps project service. Let's click on the hamburger menu and click on developer services. Let's select the DevOps projects. Alright, so let's go ahead and create a new DevOps project for Canary deployment and make sure that you are in the right compartment. Let me click on Create DevOps Project. Give this project a suitable name. Description is optional. Now you must select the notification topic. So let's click on Select Topic. Make sure you are in the right compartment. And when I select the topic drop down, I can see there are different topics listed. Must select the one that we created for Canary. So let me select this and click on Select Topic. And then let's click on Create DevOps Project. Now, as you can see, there's a notification which says Enable Logging. Let's go ahead and click on Enable Log. And let's enable the log. Let's leave everything as default. So the logs will be created in the default group and with the following log name. Let's click on Enable Log. Alright, so the logs are active now. Let's go back to the project overview. And as you can see, the notification is gone. Now the next step is to create DevOps artifacts. So let's click on Artifacts from the left menu. And let's start adding artifacts. So let's click on Add Artifact. The first artifact that we'll be adding is for our Docker image. Let's give it a suitable name. So the type of the artifact is container image repository, and you have to provide the fully qualified path to the image in the container registry. So let me provide the fully qualified path for the container repository that we created to store this image. Alright, so this is the path to my container registry where I'll be storing my images. So it starts with regionkey.ocir.io/your tenancy namespace and /your repository name. And in this demo, we'll be using the parameter from the build pipelines, which is the build_run_hash, which makes our image names unique. And you must ensure that the allow parameterization is checked. Let's click on Add. Alright, so the Docker image artifact has been added. There's one more artifact that we must add, which is the Kubernetes manifest. So let's click on Add Artifact. Give it a suitable name. Make sure the type is set to as Kubernetes manifest. Now we must select the artifact registry repository that we had created earlier. So let's click on Select and select the repository name for the Canary deployment. So let's click on this one, that one we created earlier. And let's go ahead and click Select. Under the artifact location, use the set custom location and provide an artifact name. So let me give it a name. And the version for our artifact is defined using the build_run_hash parameter. So let's put it there and make sure that the allow parameterization field is checked. Let's click on Add. There you go. So we have added both the artifacts in our DevOps project. One is our container image and another one is for the Kubernetes manifest. Alright, so let's move ahead and go and set up our code repository for this project. So let me go ahead and click on Code Repositories. So I'll be mirroring my GitHub repo, which has all the source codes for the Python application and the Kubernetes manifest. Let me take you to my GitHub repo. This is the GitHub repo and it's a forked repo from the Oracle DevRel repository where they provide all the samples which you can use to practice various DevOps features. So let me go ahead and mirror the repository. So let's click on Connection and create connection. Give this connection a name and let's select the type as GitHub. Make sure that the vault is selected where you have the personal access token stored as a secret. So this is the vault where I have the PAT stored as a secret. So this is my secret which holds my personal access token for the GitHub repository I'm mirroring. Let's select that and let's click on Create. Alright, so once the connection is set up, you will be able to see the list of repositories within your GitHub account, and from which I'll be selecting the Python OCI Canary OKE app repo, which holds all the source code and the Kubernetes manifest file. Let's click on that. For the scheduling type, let me use the custom option and let's set it to 2 minutes so that every 2 minutes the mirror is synchronized. Let's leave the name as it is, the one that is generated by default, and let's click on Mirror Repository. Alright, so as you can see, the mirroring is in progress. It will take some time before we could see all the files from my GitHub repo over here in the code repository. Alright, so as you can see, we have all the files pulled from the GitHub repo into the code repository within the DevOps project. If you recollect from the Canary deployment lesson, we must install an Nginx ingress controller to our OKE cluster. So let's go ahead and install the Nginx ingress controller. Let me go to the Cloud Shell. So in order to install the Nginx ingress controller, the first thing that we'll be doing is creating a cluster role binding with the user OCID. And this is required if your Oracle Cloud Infrastructure user is not a tenancy administrator, and you have to grant the user the Kubernetes RBAC cluster-admin cluster role on the cluster. Right, so let's go ahead and do that. So let me clear the screen. And this is the command to create a cluster role binding. So command is kubectl create cluster role binding. You have to provide a string, and you have to specify that the cluster role is cluster-admin, and you have to provide the user OCID for whom you are trying to create this cluster role binding. So let's go ahead and hit enter. Alright, so the cluster role binding for my user is created. Let me clear the screen. So the next step is to create service account and ingress controller. So for which I'll be using the following command. So this command will create the ingress Nginx controller deployment along with the Kubernetes RBAC roles and bindings, and the ingress Nginx ingress controller service of type load balancer. You must always ensure that the version that you're deploying for the Nginx controller is the latest. While I record this video, the latest version is 1.3.0. So let me go ahead and hit enter. So as you can see, the different services are getting created. The service accounts, the RBAC, the cluster role bindings, and the deployments. So this is done. You can view the list of running services using the following command, kubectl get svc-n, which stands for namespace, and the namespace is ingress-nginx. So for the ingress Nginx controller of type load balancer, we are still to get the external IP. Let's run the command again. Alright, so the ingress-nginx-controller of type load balancer is deployed with a public IP. You can also create TLS secrets, which is used for SSL termination on the ingress controller. We will be skipping that for now. Now the next thing that we have to do is define the ingress controller service as a load balancer service, for which we'll be creating a file with the service definition in it. I already have that file in my home directory. The file name is cloud-generic.yaml file. Let me spin up the code editor. So as you can see, this is the cloud-generic.yaml file. This is similar to the one that we used in the blue-green deployment demo. So this is the file of kind service where we are defining the ingress Nginx as type load balancer. Right, so let me close this code editor and let's go ahead and deploy that file using the kubectl apply command. Alright, so as you can see, the ingress-nginx ingress controller service has been created. We can validate this installation using the kubectl get svc command. Let me just fire that command. As you can see, we have this new entry for ingress-nginx service of type load balancer deployed with a public facing IP. So with this, we have completed the setup for deploying the Nginx ingress controller and the service. So I'll be stopping this video here. I hope you enjoyed the demo so far. See you in the next part. Thank you so much for watching. Hello and welcome back to this demo on deploying using Canary deployment strategy to the container engine for Kubernetes cluster, leveraging OCI DevOps project. So let's continue with our setup. Now let's go ahead and start creating our build pipeline, for which we'll have to go to our DevOps project. Let me switch to the first tab and let me select So currently I am in my DevOps project, and let me select the build pipeline. Click on create build pipeline and give this build pipeline a suitable name. Alright, so I have given name for my build pipeline. Let's click on create. Alright, so this brings us to the dashboard where we'll start creating different stages. So as we all know, the first stage is the manage build stage, which is the default stage that we must create. So let's click on add stage and click on the manage build stage and click on next. Enter the stage name. Description is optional. Let's leave everything as default. As mentioned earlier, if the build_spec.yaml file is not present in the root of your code repo, you must provide a relative path at this location. In our case, it's available in the root directory. Let's go ahead and add our primary code repository. Let's click on the select button. Choose the connection type as OCI code repo and select your code repository. Make sure the branch is selected as main and give your build source a name. Now let's save these changes. Alright, let me verify all the details. Everything looks good, so let's click on add. And as you can see, the manage build stage is added with the name build Python app. Now the next stage that we will add is the deliver artifact stage. So let's click on this plus icon over here. Click on add stage. Select the deliver artifact stage from the optional section and click on next. Give this stage a suitable name. Click on select artifacts to choose the artifacts you wish to deliver. So let's click on select artifacts and select both our artifacts, that is the Kubernetes manifest and the Docker image. So let's select both of these and click on add. Now it says associate the artifacts with the build result. So we must ensure here that the build config or the result artifact name should match with the one we have specified in the build_spec.yaml file. So let me take you to the build_spec.yaml file in my code repo. And if I open this file over here, if you scroll down to the output artifact stage, the name given for Docker image is OKE_app_base, and the one for the Kubernetes manifest is OKE_deploy_manifest. So let's use these names. Alright, so I've added both the names over here. Let me also give you a quick walkthrough of the build_spec.yaml file. So as you can see, we have the build_spec.yaml file with the exported variable set to as build run_hash, which we'll be using to generate the unique names for our image. And then in the input artifact, we are using the Golang CLI. And then within the steps, we have different commands where first we are defining the unique image tag for every image that we create out of this build run. And in the next step, what we're doing is we're using the docker build command to create a container image for our application. And then we have the output artifact stage where we'll be delivering those artifacts generated to the respective locations. Alright, so let's get back to the build pipeline. And now let's verify the details for our deliver artifact stage. Everything looks good to me, so let's click on add. Okay, so the push artifact or the deliver artifact stage is added. Now let's create the DevOps environment. So let's go to our DevOps project using the breadcrumb link. And now select the environments from the left menu. Let's create an environment. Make sure you choose the Oracle Kubernetes engine. So I've selected that. Let's give it a suitable name. And let's click on next. Now make sure you're in the right region and the right compartment. And now select the cluster that we had pre-created. So this is the one that we had pre-created. Let's select this and click on create environment. Alright, so our environment is successfully created. Now let's go back to the DevOps project. Now it's time to create our deployment pipeline. So let's click on the deployment pipelines from the left menu. Let's click on create pipeline. Give this pipeline a suitable name. Let's click on create pipeline. Alright, so as you can see, we have reached the dashboard where we can add stages to our deployment pipeline. So let's click on add stage. And this time we'll be using the canary strategy deployment option. So let's click on the canary strategy and click on next. Now let's fill up the details that are required. Make sure you select the deployment type as OKE. Give this stage a name. Select the environment that we had created in the DevOps project, which is OKE cluster. Provide a canary namespace. So let's give this canary namespace a name, NS canary stage. Now let's select the artifact. Alright, so we have to provide the Kubernetes manifest artifact. Let's click on that and click save. And if you recollect from the canary deployment strategy lesson, for the OKE deployment using canary strategy, Nginx ingress controller has to be set up, right? And we have already done that in our OKE cluster. We must also provide the Nginx ingress name that we are using. So let's provide this name. So we have already provided this name in our deployment file. Let me take you to our deployment file. So this is the deployment manifest. Let's click on it. And if you see in the deployment, we have defined ingress for our application. And let's copy this name. Let's use it over here. Verify all the details. For me, it looks good. So I'll click on next. Now, as we had studied in the theory lesson that you can have a validation control stage, which again is an optional stage where you can use a custom logic through a function to validate your rollouts. But for now, we're not using any validation control. So we'll select none and click on next. Now under the traffic shift stage, provide the name to this stage. Let me give it a name. So as we all had studied that this stage lets us shift a part of production traffic to the canary environment. So I've given it a name, canary percentage of shift, and let's give the ramp limit. So I've set the ramp limit to 25. Basically, ramp limit is set in percentage, which specifies the maximum traffic to be shifted to the canary environment. We will validate this once we run our pipelines. So let's click on next. Now we have come to the approval stage. So this is the manual approval stage, right? Let's give it a name. And let's use 1 as number of approvals required to pass this stage. Let's click on next. Now we have reached the production canary stage. So here let's provide a suitable name to this stage. Alright, so I've given this stage a name, switch to production environment. The production environment is already selected, which is our OKE cluster. We have to provide a production namespace. So this time I'll use the namespace as NS canary prod. So let's use this as the namespace NS canary PRD, and ensure that you check the auto rollback option, which will automatically roll back to the last successful version in case of any failures. So let's click on add. And as you can see, our canary stages are getting created. Alright, so it's done. Let's click on close and we can see them in our dashboard. Right, so once we have created this deployment pipeline, let's go back to our build pipeline and connect these two using the trigger deployment stage in the build pipeline. So let me go to the DevOps project, select the build pipelines, click on the build pipeline, and now let's add the trigger deployment stage. Let's click on the plus icon, click on add stage, and from the optional stages, select the trigger deployment stage, click on next, give the stage a name, and select the deployment pipeline. So this is the deployment pipeline that we had created. Let's select this and click on save changes. Alright, so let's validate all the details. Things look good to me. Let's click on add. There you go. So our trigger deployment stage has been added to the build pipeline. Now there's one last thing that's left as part of this setup is to create the namespaces in our Kubernetes cluster. So let's go to our Cloud Shell. Let me clear the screen. And let's use the kubectl create ns command to create the two namespaces that we had defined in our pipelines, that is ns canary prd and ns canary stage. So I'll be using this command to create the namespaces, right? So let's go ahead and hit enter. All right, so both the namespaces are created for us now. We can cross-validate using kubectl command, using kubectl get ns. And as you can see, our ingress nginx namespace is present and the other two that we just deployed are present. And these are the system default namespaces. All right, with this, we have completed the entire setup to demonstrate the canary deployment strategy to deploy an application on the container engine for Kubernetes. I'll stop this video here. I'll see you in the next video where we will see the entire thing in action. Thank you for watching.